In today's video, we're going to cover trigonometric functions of any angles and reference angles. We are going to start with an example here of find the exact value of the 6 trig functions when sine of theta is equal to negative 12/13 and theta is in quadrant 3. Okay, so that's going to be our question. And how do we solve this? Well, reminder that sine of theta is opposite over hypotenuse, and it is also the y value on the unit circle. Sine here is negative, so notice that we can either have, if sine is negative, sine is the y value, that means we either have an angle here, so theta would be this angle, or we have an angle somewhere over here where theta is this angle. Our problem states that it's in quadrant 3. So that would be this picture over here. The reason I pointed this out is just because why did they even say this? Theta is in quadrant 3. Well, that's to help us determine which of these two things happened. So now that we know that it's in quadrant 3, we can solve the rest of this problem. Sine is opposite over hypotenuse, where sine is also y value. That means the y value is negative 12/13. If we draw this picture, so we're going to draw a triangle here, where we have a right triangle. The y value is 12/13. The hypotenuse is 1. What is our x value? Well, we use Pythagorean theorem to solve that. So 12/13 squared plus x squared is equal to 1 squared. I just plugged this information into our Pythagorean theorem. 12/13 is 12/13 squared is 144 1/69. Plus x squared is equal to 1. This tells us that x squared is equal to 1 minus 144 1/69. That is 25 1/69. And then x is 5/13 when we take the square root of both sides. So we know what sine is. We were given that in the first place. And now we can determine the rest of our 6 trig functions. Let's start with cosine. What is cosine of theta? Cosine of theta is the x value, which we just said was 5/13, but let's be a little careful here. I was keeping everything positive for this calculation. We are actually in the 3rd quadrant, right? And so our x value is negative. So this cosine of theta is negative 5/13. Let's keep going. We got sine, we got cosine. What is 1 over sine? 1 over sine is cosecant. So cosecant of theta is 1 over sine, which is 1 over y. Or in other words, it is the negative 13/12, because it's just the reciprocal of negative 12/13. Secant of theta is 1 over cosine, so that's negative 13/5. Tangent of theta is sine over cosine, or opposite over adjacent. Sine is negative 12/13. Cosine is negative 5/13. If we reduce this, the negatives cancel. These 13s in the denominator cancel. We just get 12/5. And then cotangent is, of course, 1/tangent. So we, in fact, here get 5/12 for cotangent. And that's it for example 1. I'd like to move on and discuss reference angles real quick. Oh, not example 2. We want to talk about reference angles. And what is a reference angle? So we have 4 pictures here where an angle can be in quadrant 1, an angle can be in quadrant 2, an angle can be in quadrant 3, and an angle can be in quadrant 4. The reference angle is the angle between between 0 and 90 degrees that is the distance, the angular distance, between the terminal side let's call this of theta, so let's call this angle theta. All of these angles are theta. Between the terminal side of theta and the x-axis. Okay. What does that mean? Well, in this first picture, when theta is in the first quadrant, theta and the reference angle are the same. Okay. Sometimes you'll see the reference angle as theta bar, so with a little bar over it. So I'll write that in here. Theta bar. The reference angle is theta bar. And that's an angle between 0 and 90 degrees, and it is the, I should say, angular distance between the terminal side of theta and the x-axis. All right, so what would theta bar, or the reference angle, be here when theta is in quadrant 2? Well, that's this part right here. Right, this is the angle between theta and, which is here, and the x-axis. And it's between 0 and 90 degrees, so I didn't go this way. I went this way. Theta bar is here, or the reference angle is here, when theta is in the third quadrant. And it's here when theta is in the fourth quadrant. So again, what is it? It's just some angle between 0 and 90 degrees that tells you the angle between the x-axis and your terminal side. Okay. Now, why is that useful? Let's do an example, or a couple of examples. Actually, we'll just start with calculating the reference angle first. Then we'll do an example to see why that is important. So example 2. Find the reference angle for, and we'll do A. A is 5 pi over 4. Well, first thing we should do, at least at the beginning, is draw this down. 5 pi over 4, we got 1 pi over 4 here, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is down here. So our angle is here. The reference angle is this portion. Well, what is that distance in angles? Well, this angle is pi. So if we go from pi to 5 pi over 4, that angle is just pi over 4, right? We have 5 pi over 4 minus 4 pi over 4, so this is just pi over 4. So that's our reference angle. We'll do a second example, real quick second example. And that is negative 150 degrees. Well, let's draw the picture again. If we go down this way, that's negative 90. Here is negative 180. So negative 150 is about here. Again, we're in the third quadrant. So again, this is our reference angle. And what is the distance between those? Well, we take our angle, negative 150, and we subtract off the negative 180, which is really an addition now, and this gives us 30 degrees. And so it's 30 degrees between negative 150 and negative 180. Now, let's see how that can be useful. So we'll see that in example 3. Use reference angles to find the exact values or exact value of tangent of 405 degrees. Okay. Actually, in this one, it'll be more about using coterminal angles than anything else, but it'll be the same idea. What do we want to do? Well, 405 degrees, first we should convert that to something between 0 and 360. And notice that 405, tangent of 405 degrees should be equal to tangent of 405 minus 360, which we know from previous sections, which is tangent of 45 degrees. Tangent of 45 degrees we know, and also it's in the first quadrant. So our reference angle is the same as the angle we were given, the 45 degrees. So our reference angle is 45 degrees, and we know that the original angle here is 45 degrees, or is equivalent to 45 degrees. So what is tangent of 45? Well, that is 1, because our sine and our cosine are the same here, so they will cancel out to be 1 when we do sine over cosine. All right, so tangent of 45 is 1, which is our tangent of 405. I'm going to call that part A because we are going to want to do one more example here. I'm going to do find the reference angle of, find the reference angle to find the exact values of, and let's do tangent of negative pi over 6. Okay. Well, let's draw the picture again. Negative pi over 6 goes down here by pi over 6. Okay. So this is pi over 6. And then what is our reference angle? Well, our reference angle is pi over 6. Because that's the distance between the x-axis here and this angle. Sorry, that actual angle is negative pi over 6. The angular distance between the two is positive pi over 6. So reference angle is pi over 6. What is tangent of pi over 6? Well, this is sine of pi over 6 over cosine of pi over 6. These two values, these are values that you should know from the previous sections. So we should know those values off the top of our head. Sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. So this is 1 over root 3. And we're almost done. Except tangent, we found tangent of positive pi over 6. What we really want is tangent of negative pi over 6. But the thing is, that's going to be related to tangent of positive pi over 6. Picture's a little off here. But we see that there's this triangle up here in the first quadrant, the same as this triangle here. So we're going to have the same values as far as cosine, sine, or tangent go, or the other three as well. But some of them may be negative, some of them may be positive. What is tangent in the fourth quadrant? Well, tangent is negative because tangent is sine over cosine. Sine is negative, cosine is positive. So we get a negative over a positive. So the tangent of an angle that is in the fourth quadrant should be negative, but its value is related to tangent of this reference angle of positive pi over 6. So this is in fact just negative 1 over root 3. And that finishes our question. We were able to find the exact value of tangent of negative pi over 6 by using reference angles and converting everything to the first quadrant. And once we do that, we can pretty easily determine what this value is. And that ends today's video.